For months, our attention has been fixed on a visitor from deep space. An interstellar object called 3I Atlas, glowing softly as it drifts through our solar system. Headlines asked if it could be dangerous. Scientists watched closely. But tonight, the truth is calmer than the fear. 3I Atlas is harmless. While we were looking far away, something much closer has been moving quietly through the dark. In just a few years, an asteroid named Apophis will pass closer to Earth than anything like it in recorded history. There is no need for fear. But there is a story worth telling, slowly, gently, and with care. Tonight, we explore what Apophis really means, and why understanding it may help us rest easier. Coma looked dramatic, but careful study shows it poses no danger at all. When the first reports of 3I Atlas appeared, they carried a quiet sense of drama. Astronomers noticed a faint object moving through the outer reaches of our solar system on a path that did not match the familiar patterns of planets or long-known comets. Its direction and speed suggested it came from far beyond our sun's influence, from the deep space between stars. Almost immediately, attention followed. News outlets shared images, social media filled with speculation, and the idea of an interstellar visitor captured imaginations around the world. For many people, the word interstellar alone was enough to spark concern, because it points to something unknown, something that does not belong to our usual neighborhood. As telescopes focused in, the object revealed a glowing cloud around it, known as a coma. This coma reflected sunlight and spread outward in a way that looked dramatic in images, especially when enhanced for clarity. To someone scrolling late at night, the pictures could feel intense, even ominous. The glow looked large, and without context it was easy to think size meant danger. Our minds are wired to react quickly to visual signals, and bright shapes moving through space can trigger old instincts meant to protect us. Even calm people can feel a subtle tension when something unfamiliar appears above us, moving silently through the dark. But science moves more slowly than fear and with careful steps. As more observations came in, astronomers began to measure the object's path, speed, and composition. They compared it with other known visitors that had passed through before. They looked at how light reflected off its surface and how the coma behaved as it interacted with solar radiation. Each piece of data added a little more clarity, and with that clarity came reassurance. The path of 3I Atlas was calculated with precision, and those calculations showed it would never come close to Earth. Its trajectory was stable and distant, a graceful curve that carried it through the solar system and back out again. The coma, which had drawn so much attention, also became easier to understand. It was not a sign of aggression or instability, but a natural response to sunlight warming the surface of the object. As frozen gases met heat, they gently released into space, forming that glowing halo. This is a process seen with many comets, though the interstellar origin made it feel more exotic. In reality, the physics were familiar and well understood. The light made it visible, but it did not make it powerful. The object remained small on a cosmic scale, and its mass was nowhere near enough to influence planets or the sun in any meaningful way. Still, the story spread faster than the details. Headlines often lean toward excitement because excitement captures attention. Phrases like mysterious visitor or unknown object can suggest risk even when none exists. For people already tired at the end of the day scanning headlines without context, the emotional tone can feel heavier than the facts. This is how distraction begins, not through intention but through imbalance. When dramatic framing outweighs calm explanation, our focus shifts from understanding to worry. In truth, 3I Atlas offered scientists something rare and valuable, a chance to study material formed around another star. That alone is remarkable. It means we can compare what exists beyond our solar system with what we know at home. The object became a traveling message from far away, not a threat, but a source of quiet information. Its presence allowed researchers to refine models of how stars form planets, how material moves between systems, and how common such visitors might be across the galaxy. These are slow questions answered over years, not moments. As days passed and updates continued, the tone among experts remained steady. There were no emergency meetings, no warnings issued, no changes to daily life suggested. Observatories simply kept watching, recording, and learning. The object moved on, just as predicted, following the path drawn by gravity long before humans ever noticed it. For those who took the time to listen to the full story, the tension faded. What remained was a sense of wonder, calm and grounded, the kind that reminds us the universe is active but not hostile. Yet the initial distraction lingered in memory. It showed how easily attention can be pulled outward, toward distant possibilities, while closer realities remain unnoticed. The glow of 3I Atlas became a symbol of how something harmless can dominate conversation simply because it feels unfamiliar. This is not a failure of intelligence but a reflection of human nature. We are drawn to the new and the unknown, especially when it appears in the sky, a place we have always watched with curiosity and caution. As the object continued its journey, it quietly confirmed something important. Space is filled with movement, with travelers passing through without consequence. Most of these motions have been happening for billions of years, long before we named them or tracked them on screens. Our planet has always existed within this flow, shielded by distance, gravity, and time. Understanding this can be grounding. It can lower the volume on fear and raise the level of perspective. 3I Atlas did not change our skies, our oceans, or our future. It did not disturb the sun or tug at Earth's orbit. It did not bring danger or demand action. Instead, it reminded us that not every bright thing in the dark is a warning. Some are simply passing through, offering a brief chance to observe and learn before they fade back into the vast quiet they came from. And while attention rested on that distant glow, moving calmly and predictably through space, other stories much closer to home continued to unfold, unnoticed by most, waiting patiently in the background as curiosity slowly shifts and the night remains calm and open, with thoughts drifting gently forward into the next part of the journey without urgency or alarm, allowing the mind to stay relaxed and attentive as the narrative continues to move along in a steady, unbroken rhythm that feels natural and unforced, like watching stars slide across a clear sky while breathing slowly and evenly, remaining present with the flow of information as it carries on without pause. When something comes from outside our solar system, it touches a very old part of the human mind. For as long as people have looked up at the night sky, the space beyond our familiar planets has felt distant, silent, and unknown. We know the moon. We know the sun. We know the slow paths of the planets that return again and again in predictable ways. But an interstellar object does not belong to this familiar family. It comes from somewhere else entirely, from a place we cannot easily imagine, and that difference alone can make it feel unsettling. The human brain is built to notice changes in its environment. Long ago this helped our ancestors survive. A strange sound in the dark or an unfamiliar shape on the horizon could signal danger. Even today this instinct remains. When we hear that an object has entered our solar system from deep space, it feels like a sudden change in something we thought was stable. The sky, which usually follows patterns we can track and predict, has been interrupted by something new. That sense of interruption can quietly trigger fear, even when no real threat exists. Interstellar objects also challenge our sense of control. Most things that move near Earth have been studied for decades. Scientists know where many asteroids came from, how they formed, and how they behave. But objects from beyond our solar system carry a different story. They were shaped by other stars, other environments, and forces we have never directly observed. When people hear this, it can feel like science has fewer answers, even though researchers often understand far more than headlines suggest. Another reason these objects feel scary is how they are often presented. News stories tend to focus on what is unusual or dramatic. Words like mysterious, unknown, or unexplained catch attention quickly. Images of glowing comas or long tails stretching across space look striking and unfamiliar. When these visuals are paired with urgent language, the mind fills in gaps with imagination. Fear grows more easily in those empty spaces than calm understanding does. There is also the influence of science fiction, which has shaped how many people think about space. For decades, movies and books have shown objects arriving from beyond the stars as signs of danger, invasion, or disaster. These stories are powerful and they stay with us. Even when we know they are fictional, they can quietly influence how we feel. When a real interstellar object is discovered, it can awaken memories of those stories, blending imagination with reality in ways that are hard to separate. Unfamiliar motion adds to this discomfort. Objects that orbit the sun usually follow paths we recognize. Interstellar visitors often move faster and on steeper angles, cutting through the solar system rather than circling within it. To scientists, this is simply physics, a result of gravity and momentum. To the average person, it can feel erratic or unpredictable. Anything that appears unpredictable tends to feel more dangerous, even if it is not. There is also the question of scale. Space objects are enormous compared to everyday life. Even a small asteroid can be larger than a city. When people hear about sizes measured in miles or kilometers, the numbers can be hard to picture. The mind struggles to relate, and when understanding fades, fear can step in. It is easier to feel anxious about something we cannot clearly imagine than something we understand well. At the same time, space feels personal in a quiet way. The sky hangs over all of us. We sleep beneath it, travel beneath it, and build our lives under its steady presence. When something unfamiliar enters that shared space, it can feel closer than it really is. Even if an object is millions of miles away, the idea that it passes through the same cosmic neighborhood can make it feel near and immediate. Social media also plays a role in amplifying fear. Short posts and quick videos often remove nuance. A calm scientific explanation does not spread as fast as a shocking claim. As people share and react, fear can grow faster than facts. This does not happen because people want to be misled, but because emotional responses are faster than careful thought. Fear spreads quickly, especially when the subject feels large, distant, and hard to verify personally. Despite all this, science has become very good at studying these visitors. Telescopes can measure their speed, their shape, and their distance with incredible accuracy. Spectral analysis can reveal what they are made of, whether rock, ice, or dust. Orbital calculations can show where they came from and where they are going. In most cases, scientists can determine within days whether an object poses any risk to Earth. The challenge is not a lack of knowledge, but a gap between what scientists know and what the public often hears. It is also important to remember that interstellar objects have likely passed through our solar system many times before. We simply did not have the technology to see them. Now that our instruments are better, we are noticing what was always there. This can feel like an increase in danger, but it is actually an increase in awareness. The universe has not suddenly become more threatening. We have simply opened our eyes wider. Fear often fades when understanding grows. When people learn that gravity guides these objects, that their paths can be calculated, and that distance in space is vast beyond everyday comprehension, the sense of threat softens. What once felt like an intruder begins to feel more like a traveler passing through, following the same physical laws as everything else in the universe. Interstellar objects remind us that we live in a dynamic cosmos, not a fragile one. The solar system is not a closed room but part of a much larger space filled with motion and exchange. While that idea can feel unsettling at first, it can also be comforting. It shows that Earth has existed through countless cosmic events and continues to move forward, stable and protected by distance, gravity, and time. As fear gives way to curiosity, these visitors become opportunities rather than threats. They offer clues about other star systems, other worlds, and the shared materials that build planets everywhere. They help scientists learn how common certain elements are and how solar systems form and evolve. Instead of signaling danger, they quietly expand our understanding of where we come from and how connected the universe truly is. In the end, the fear surrounding interstellar objects says more about human psychology than about space itself. The unknown has always felt powerful, especially when it comes from places we cannot reach. But each new discovery also carries reassurance, showing that the universe follows rules, patterns, and rhythms that can be studied and understood, even when they first appear strange and unfamiliar. When scientists first became aware of 3I Atlas, the early response was calm and methodical. Long before headlines began to speculate or social media filled with dramatic guesses, researchers started doing what they always do when something new appears in the sky. They measured its speed, its path, and its brightness. They compared those numbers to known objects that have passed through our solar system before. This process is slow, careful, and grounded in math and physics, not emotion. Almost immediately, these early calculations began to paint a clear picture of what 3I Atlas is and, just as important, what it is not. One of the first things scientists ruled out was any chance of a collision with Earth. The object's trajectory showed that it would remain far beyond our planet at all times. Its path is steep and angled, carrying it through the inner solar system briefly before continuing outward again. This kind of path is common for interstellar visitors, which are not bound to the sun the way planets or long-term comets are. By plotting its motion forward in time, researchers could see that there was no scenario in which 3I Atlas came anywhere close to Earth. Even at its nearest point, it would still be millions of miles away, far beyond any reasonable definition of danger. Scientists also ruled out any meaningful interaction with the sun. While 3I Atlas does pass closer to the sun than Earth does, it remains well within ranges that many comets and asteroids travel safely. The sun is immense and powerful, but it is also predictable. Researchers know exactly how solar gravity works and how it affects passing objects. Calculations showed that 3I Atlas would not trigger unusual solar activity, flares, or disruptions. The sun has absorbed and deflected far larger objects over billions of years without incident, and this visitor is simply not large or massive enough to cause any change. Another concern that scientists addressed early on was whether 3I Atlas could somehow disturb Earth's orbit or magnetic field. This idea may sound dramatic, but it has no basis in physics. For an object to affect Earth in this way, it would need to be extremely massive and very close. 3I Atlas is neither. Its mass is small compared to planets, and its distance ensures that its gravitational influence on Earth is essentially zero. Instruments and models confirmed that Earth's orbit, rotation, and magnetic shield would remain completely unchanged as the object passed through the solar system. Researchers also examined whether 3I Atlas could break apart and send debris toward Earth. This is something scientists consider when tracking comets, especially those that pass close to the Sun and sometimes fragment. In this case, observations showed no signs of instability. The object's structure appeared consistent and steady, with no sudden changes in brightness or movement that would suggest fragmentation. Even if small particles were released, they would disperse harmlessly into space and never reach Earth. Space is vast, and tiny fragments spread out quickly, losing any chance of concentrating into a threat. Another idea that scientists dismissed was the possibility that 3I Atlas was artificial or controlled. While it is natural for the human mind to wander toward imaginative explanations, astronomers rely on evidence. The motion of 3I Atlas followed the laws of gravity exactly as expected. Its acceleration, rotation, and light patterns matched what scientists see in natural objects made of rock, ice, and dust. There were no signs of propulsion, no unexpected course changes, and no signals of any kind. Everything about its behavior aligned with known physical processes. Scientists also confirmed that 3I Atlas posed no long-term risk to future generations. Even after it leaves the inner solar system, its path will carry it far away, likely never to return. Interstellar objects move quickly, and once they pass through, they are gone. There is no scenario in which 3I Atlas settles into an orbit around the Sun or lingers in a way that could create problems later. This brief visit is a one-time event, a momentary crossing of paths between distant regions of space. As more data came in, confidence grew. Multiple observatories across the world confirmed the same results. Independent teams ran their own calculations and reached the same conclusions. This agreement is important in science because it reduces the chance of error. When many experts using different tools all arrive at the same answer, it becomes very reliable. In this case, that answer was clear and steady. 3I Atlas is a fascinating object, but it is not dangerous. The role of scientists in moments like this is not to dismiss curiosity, but to guide it. They understand that people are naturally interested in unusual cosmic events. At the same time, they know how easily fear can grow when information is incomplete. By sharing clear findings early, researchers help prevent unnecessary worry. They focus on what can be measured, tested, and verified, rather than what sounds dramatic. This careful approach reflects decades of experience. Astronomers have tracked thousands of near-Earth objects, comets, and asteroids. Each time something new appears, the same questions are asked and the same methods are applied. Over time, this process has proven reliable. It allows scientists to separate genuine risks from harmless visitors. In the case of 3I Atlas, every step of this process pointed toward safety. While public attention often moves quickly from one concern to the next, scientific understanding moves steadily. The conclusions about 3I Atlas did not change because the evidence did not change. As days passed and the object continued its journey, it behaved exactly as predicted. This consistency reinforced what scientists had already determined from the start. There were no surprises, no sudden shifts, and no hidden effects. In the end, what scientists ruled out is just as important as what they discovered. They ruled out impact, disruption, interference, and danger. What remained was a rare opportunity to study material from another star system, drifting quietly through our own. The object became a subject of learning rather than fear, a reminder that space can be full of motion and mystery without being hostile or threatening. While so many eyes were turned outward, watching the dark space beyond our solar system, something else was moving much closer to home. It was not loud, and it did not glow brightly in the night sky. It did not arrive suddenly or announce itself with dramatic headlines. Instead, it continued along a path it had been following for years, quiet and steady, guided only by gravity and time. This is often how the most important stories in space unfold, not with sudden flashes, but with slow motion that is easy to overlook when our attention is pulled elsewhere. Human attention has a natural habit of drifting toward what feels distant and mysterious. An object arriving from another star system feels dramatic, almost like a visitor from another world. It carries the weight of the unknown, and that makes it easy to focus on. Meanwhile, objects that have been part of our own cosmic neighborhood for decades can seem ordinary, even when their paths bring them very close to Earth. Familiarity has a way of dulling urgency, even when the facts deserve careful thought. As scientists tracked 3I Atlas, running models and sharing images, another object was continuing its long orbit around the Sun. It had been discovered years earlier, logged, measured, and carefully followed. There were no surprises in its movement, no sudden changes that demanded breaking news alerts. It simply moved forward, one moment at a time, circling the Sun the way countless asteroids have done for billions of years. This quiet motion is exactly what makes it easy to forget that space is not empty, and that our solar system is filled with travelers on long looping paths. This closer object did not come from the distant stars. It was born much nearer, likely formed from the same early material that shaped the planets themselves. It carries no mystery of interstellar origin, no strange chemical signature from another system. And yet, its path would soon bring it closer to Earth than almost anything of its size ever recorded. The difference was not danger but proximity, and proximity often matters more than origin when we talk about real-world effects. The way attention works can shape public understanding. When news cycles focus on one story, other important developments can quietly move forward without notice. In space science this happens often. A bright comet steals the spotlight while a less flashy but more relevant object continues its approach. Scientists are trained to watch everything at once, but the public eye naturally follows the most dramatic image, the most striking headline, or the most unusual claim. This does not mean that the quieter object was ignored by researchers. Far from it. Astronomers had been tracking it continuously, refining its orbit, improving measurements, and running simulations to understand exactly where it would be years into the future. Data was being collected patiently, without urgency, because urgency was not required. The calculations were stable, the predictions clear, and the science calm. But calm science rarely competes well with exciting speculation. As months passed, the object moved closer along its predictable route. Its distance from the Sun slowly changed, its speed adjusted according to the pull of gravity, and its future position became even more certain. This is the strength of orbital science. Once an object's path is well measured, its future can be known with remarkable accuracy. There was no guesswork involved, only careful observation and math that had been tested again and again. Yet outside scientific circles, the focus remained elsewhere. Social media, headlines, and online discussions stayed fixed on the idea of an interstellar visitor. That story felt new and thrilling, while the quieter approach of a known object felt almost boring by comparison. This contrast highlights a common gap between what feels important and what actually deserves steady attention. The idea that something closer could matter more is not always intuitive. Distance often feels like safety. If something is far away, it seems harmless. If it is familiar, it feels less threatening. But in space, distance and familiarity can be misleading guides. What truly matters is trajectory, timing, and interaction. An object that passes millions of miles away, no matter where it comes from, has little effect. An object that passes extremely close, even if well understood, can offer lessons that matter deeply. This quiet journey closer to Earth was not a threat, but it was meaningful. It represented an opportunity to observe gravity at work, to watch how Earth's presence subtly affects a passing body, and to test our understanding of orbital mechanics in real time. These moments do not happen often. They arrive on long schedules, spaced decades apart, and when they do, they offer a rare chance to learn. While public attention remained fixed on the distant, the near continued forward, steady and patient. This contrast is a reminder that space does not operate on human timelines or news cycles. Objects do not speed up because we are watching, and they do not slow down because we are distracted. They move according to forces that have been in place since long before humans looked up at the sky. In this way, the story becomes less about danger and more about awareness. It shows how easy it is to miss important developments when focus is narrowed too tightly. It also shows the quiet confidence of science, which does not need excitement to remain effective. Calculations continue, data accumulates, and understanding grows whether or not the public is paying attention. As the object continued its path, scientists prepared instruments, planned observations, and coordinated across countries. Telescopes were scheduled, radar systems readied, and models refined. None of this required alarm. It required patience, cooperation, and trust in the methods that have guided space science for generations. The quiet approach also carries a symbolic weight. It reminds us that the universe is active even when it feels still, that motion is constant even when unseen. While dramatic visitors capture imagination, the steady movements closer to home often shape the most meaningful discoveries. Paying attention to both, without fear and without distraction, allows a deeper understanding of the sky above and the forces that guide it, continuing forward in calm motion as Earth moves along its own familiar path around the Sun. When astronomers first spotted the object now known as Apophis in 2004, it appeared as a faint point of light moving slowly against the background of stars. At first it did not seem special. Objects like this are found all the time as telescopes scan the sky, quietly logging rocks that circle the Sun. But as scientists began to track its motion more carefully, something unusual became clear. This asteroid was not just another distant traveler. Its orbit would bring it surprisingly close to Earth in the future, close enough to catch the attention of researchers and, eventually, the public. Apophis is large by asteroid standards. It measures roughly 340 meters across, about the length of 3 football fields placed end to end. That size alone makes it worth watching. Asteroids of this scale are not common, and they carry enough mass to cause serious damage if they ever collided with a planet. From the beginning, scientists focused on learning everything they could about its path, speed, and shape, using radar signals, optical telescopes, and careful mathematical models to predict where it would travel over time. As data improved, early worries about a possible impact were addressed. With better measurements, scientists were able to rule out a collision with Earth during its upcoming passes. The calculations showed that Apophis would miss our planet, not by a small margin, but by a distance that kept us safe. Still, the numbers revealed something extraordinary. In April of 2029, Apophis would pass closer to Earth than many of the satellites we rely on every day. It would come well inside the orbit of geostationary satellites, a region of space that humans normally consider our own. This close approach is what makes Apophis so important. It is not a threat, but it is a rare opportunity. No asteroid this large has ever been observed passing so near while modern science is watching. For scientists, this is like being given a front-row seat to a natural experiment that usually happens far away and unseen. The gravity of Earth will tug gently on the asteroid as it passes, and that tug may cause subtle changes that can teach us a great deal about how these ancient objects behave. Apophis is believed to be made of rock and metal, a remnant from the early days of the solar system. Long before Earth formed oceans or life appeared, pieces like Apophis were already circling the young Sun. Over billions of years, many of them collided, broke apart, or were swept up by planets. Apophis survived that long history, quietly orbiting until human technology became advanced enough to notice it. In that sense, it is a messenger from a time before our world looked anything like it does today. As it approaches Earth, scientists expect that our planet's gravity could slightly alter the asteroid's rotation. Apophis may begin to tumble differently, or its spin could speed up or slow down. Loose rocks on its surface might shift or slide, revealing fresh material underneath. These changes would not be dangerous, but they would be fascinating. They would help researchers understand how gravity affects rubble pile asteroids, which are not solid chunks of stone, but collections of rock held together by weak forces. This knowledge matters because many near-Earth asteroids share similar structures. If humanity ever needs to gently redirect an asteroid in the future, understanding how these bodies respond to gravity and force will be essential. Apophis offers a chance to study these effects naturally, without any spacecraft needing to intervene. Observatories around the world, and even in space, are already planning to watch closely as the asteroid makes its historic flyby. For people on Earth, Apophis will also be a visual event. In some parts of the world, the asteroid may be visible to the naked eye as a slow-moving point of light crossing the sky. It will not streak like a meteor or flare brightly like a comet. Instead, it will drift calmly, a quiet reminder that our planet exists within a busy cosmic neighborhood. Seeing it may inspire a sense of wonder rather than fear, especially when people understand that it poses no danger. The story of Apophis also highlights how far planetary science has come. Just a few decades ago, an object like this might have passed unnoticed until it was long gone. Today it is tracked years in advance, its orbit mapped with precision, its future movements predicted with confidence. This progress did not happen by accident. It is the result of steady investment in science, global cooperation, and a shared desire to understand the space around us. Apophis is not new, and it is not rushing toward Earth with malicious intent. It is following a path shaped by gravity, the same force that keeps the Moon in orbit and the planets circling the Sun. Its upcoming close pass is part of that natural rhythm. By paying attention to it, scientists are not reacting to a threat, but listening to what the universe is showing them, calmly and carefully. As the years move closer to 2029, Apophis will continue its silent journey, growing slightly brighter in telescopes as it approaches, then fading again as it moves away. Each observation adds another piece to a long, detailed record, helping researchers refine their understanding of near-Earth objects. This steady flow of data builds confidence, replacing uncertainty with knowledge and fear with familiarity. In a way, Apophis represents a shift in how humanity relates to space. Instead of seeing it as a source of sudden danger, we are learning to view it as a place that can be studied, understood, and prepared for. The asteroid's close approach is not a warning of disaster, but a reminder that the universe is active and dynamic, full of motion that usually unfolds far from our notice, and that by watching patiently and thinking clearly, we can learn to live with that motion as part of our larger story. In April of 2029, something rare and quietly remarkable will happen in the skies above Earth. An asteroid named Apophis will pass by our planet at a distance so close that it will slip inside the orbits of many of our artificial satellites. For most of human history, events like this would have gone completely unnoticed, hidden in the dark and silent background of space. But this time is different. This time, humanity knows it is coming, has measured its path, and will be watching calmly as it passes by. The flyby of 2029 is not a moment of danger, but a moment of awareness, one that shows how far our understanding of the cosmos has come. Apophis will approach Earth at a distance of about 20,000 miles, which in space terms is incredibly close. To put that in perspective, many communication and weather satellites orbit farther away than Apophis will be during its closest approach. Despite how close that sounds, the asteroid will remain safely outside Earth's atmosphere. There will be no impact, no collision, and no physical threat to the planet or its people. Instead, there will be a silent passage, a steady movement through space, guided by gravity and motion that scientists have tracked with great care. What makes this flyby especially unique is that Apophis will be visible to the naked eye from parts of the world. No telescope will be required for many observers. For those in regions with clear skies, the asteroid may appear as a small moving point of light, drifting slowly across the stars. It will not streak like a meteor, and it will not flare brightly like a comet. Its movement will be gentle and steady, noticeable only to those who take the time to look. This quiet visibility connects modern observers to ancient skywatchers, who once relied only on their eyes and patience to understand the heavens. The timing of the flyby adds to its significance. April 2029 will mark the first time an asteroid of this size passes so close while being so well understood in advance. Apophis is estimated to be about 1,000 feet wide, large enough to cause serious damage if it ever were to strike Earth, but during this flyby it will remain a visitor, not a threat. Scientists have calculated its orbit again and again, refining their models with radar data and observations from around the world. Each new calculation has brought greater certainty and peace of mind. As Apophis approaches, Earth's gravity will gently reach out and interact with it. This gravitational pull will not pull the asteroid in, but it will influence its motion in subtle ways. Scientists expect that the flyby may slightly change Apophis's rotation, possibly causing it to wobble or spin a bit faster or slower. The surface of the asteroid may also respond, with loose rocks shifting or settling as Earth's gravity tugs at it. These changes will be small, but they offer scientists a rare chance to see how an asteroid behaves during a close planetary encounter. The flyby is also a powerful reminder of how space is not empty or distant, but active and dynamic. Objects are constantly moving through the solar system, guided by gravity and time. Most pass by without notice, and some burn up harmlessly in Earth's atmosphere as tiny meteors. Larger objects like Apophis are far less common, and even rarer are those that pass this close while being fully tracked. The fact that this flyby will happen quietly, without surprise, speaks to the progress of modern astronomy. For people watching from Earth, the experience will likely feel calm and even inspiring. There will be no loud sounds, no visible changes to the environment, and no disruption to daily life. The asteroid will glide through the sky, reminding us that our planet exists within a larger system that continues to move and change. For many, simply knowing that this object is passing nearby may spark a sense of curiosity rather than fear. Scientists around the world are already planning observations for the 2029 flyby. Telescopes on Earth and possibly in space will study Apophis as it approaches and recedes. Radar systems will bounce signals off its surface, allowing researchers to map its shape and motion with incredible detail. These observations will help improve our understanding of asteroids in general, including how they form, how they move, and how they respond to gravitational forces. The flyby also offers an opportunity to test planetary defense systems and prediction models. While Apophis itself is not a threat, the data gathered during its passage will help scientists prepare for future objects that might one day require action. Understanding how accurately we can predict an asteroid's path, and how gravity affects that path during close encounters, is essential for long-term safety. In this way, the flyby becomes a kind of rehearsal, carried out under calm and controlled conditions. Public interest in Apophis is expected to grow as 2029 approaches. News outlets, science programs, and educational institutions will likely share information to help people understand what they are seeing and why it matters. This shared experience has the potential to bring people together around a sense of wonder, rather than alarm. Seeing an asteroid pass safely by can shift perspectives, reminding us that not every cosmic event is a disaster waiting to happen. The name Apophis itself comes from ancient mythology, which may sound dramatic, but the reality of the flyby is grounded in careful measurement and clear science. The asteroid follows the same physical laws as every other object in the solar system. Its motion is predictable, its behavior understandable, and its future well charted. The story of the 2029 flyby is not about chaos, but about order, precision, and knowledge. As the date draws closer, the sky will look much the same as it always has. Stars will shine steadily, planets will follow their paths, and Earth will continue its rotation. Apophis will enter this familiar scene briefly, moving quietly against the background of space. For a short time, it will be a reminder that we are not isolated, that our planet shares space with countless other travelers, each on its own journey around the sun. For those who choose to watch, the experience may be simple and peaceful. Standing under the night sky, seeing a small point of light move where no planet usually travels, can inspire a sense of connection to the wider universe. It is a moment that blends ancient wonder with modern understanding, showing how observation and knowledge can replace fear with calm awareness. The flyby of 2029 will pass quickly, and Apophis will continue on its orbit around the sun, gradually fading from view as it moves farther away. Life on Earth will go on unchanged, but the memory of the event will remain as a marker in our relationship with space. It will stand as an example of how awareness, preparation, and science allow us to coexist peacefully with the dynamic environment beyond our planet, watching quietly as the universe moves around us.
For most of human history, the sky has felt distant and untouchable. The stars moved slowly, the planets followed steady paths, and anything beyond the moon felt safely far away. Even when people imagine rocks falling from the sky, those events belong to legends, ancient stories, or distant geological time. In modern life, space often feels like something we observe through screens and images, not something that reaches toward us. That is why the coming passage of asteroid Apophis feels so different. It is not just another object passing silently in the background of space. It is something large, real, and measurable, moving closer than anything of its kind ever has while human eyes and instruments are actively watching. Apophis is not a small rock flashing by unnoticed. It is hundreds of meters wide, large enough to be tracked clearly, studied carefully, and imagined easily. When scientists say it will pass closer than anything in recorded history, they are not speaking casually. They are comparing this moment to centuries of observations, calculations, and records. Never before has an asteroid of this size come so close to Earth at a time when we have telescopes, satellites, computers, and global communication all focused on the same event. This makes the flyby unique not just in distance but in awareness. In earlier times, an asteroid could have passed close to Earth and no one would have known. People would have gone to sleep unaware, and the object would have continued on its way without a single note written about it. Today, the situation is very different. We track the sky constantly. We calculate orbits years and even decades ahead. We simulate paths using powerful computers, checking again and again for accuracy. Because of this, the closeness of Apophis feels personal. It is not just happening near Earth. It is happening while we are paying attention. The idea that something so large can pass so near challenges the quiet sense of distance many people carry inside. It reminds us that Earth is not isolated in space. It moves through a busy environment filled with rocks, dust, and debris left over from the formation of the solar system. Most of the time, These objects stay far away. Their paths never cross ours in any meaningful way. But Apophis is an exception, and exceptions stand out because they break our expectations. When scientists describe the flyby, they often compare the distance to familiar objects. Apophis will pass closer than many satellites that orbit Earth. This comparison makes the event easier to picture. Satellites feel close. They're part of our daily lives, supporting communication, weather forecasts, and navigation. To imagine an asteroid moving through that same region of space feels strange, even unsettling, not because it is dangerous, but because it feels out of place. Despite this closeness, there is an important calm truth that scientists repeat often. Apophis will not hit Earth in 2029. Its path has been calculated with great care, and the margin of safety is well understood. The closeness does not mean risk. It means opportunity. It means a chance to observe something rare and learn from it in ways that have never been possible before. Still, the emotional weight of the moment is real. Knowing that an object of this size is passing so close while we are alive creates a sense of shared experience. It is something people across the world will know about at the same time. In some parts of the world, Apophis will be visible to the naked eye. People will step outside, look up, and know they are seeing a visitor that has traveled through space for millions of years, now briefly sharing our neighborhood. This awareness changes how the event feels. It becomes more than data and numbers. It becomes a moment in human memory. Long after the asteroid has passed, people will remember where they were when they heard about it, or when they looked up and tried to spot it. Scientists, students, and curious observers will all share the same reference point. That shared moment is what makes this flyby stand apart from others. The phrase, once in a lifetime, is often used too easily, but in this case it fits. Most people alive today will never see another asteroid of this size pass, so close with such certainty and visibility. Future generations may witness similar events, but this one belongs to us. It is part of our time, our era of observation and understanding. There is also a quiet sense of reassurance in this moment. The fact that we know about Apophis years in advance shows how far human knowledge has come.
We are not surprised by it.
We are not guessing. We are prepared. This knowledge turns what could feel frightening into something thoughtful and calm. Instead of reacting in fear, we can respond with curiosity. As Apophis approaches, scientists will watch how Earth's gravity affects it. They will measure changes in its rotation, its surface, and its path. These details help us understand not just this asteroid, but many others that share similar orbits. Each measurement adds to a growing body of knowledge that quietly improves our ability to predict and protect. For people outside the scientific world, the event offers something simpler. It offers perspective. It reminds us that Earth exists within a larger system that is active and dynamic. The sky is not static. It moves, shifts, and occasionally brings surprises. Most of the time, these movements are gentle and harmless, even beautiful when viewed with understanding. The closeness of Apophis also brings attention back to Earth itself. Watching something pass by without harm highlights the balance that keeps our planet safe most of the time. Gravity, distance, and motion all work together in steady patterns. Apophis is a reminder of those patterns, not a break from them. As the date approaches, the story of Apophis will continue to unfold quietly. Updates will be shared, images will be released, and simulations will be refined. Each step will bring more clarity, not more danger. The asteroid will move along its path, Earth will continue its orbit, and life will go on as it always has. The memory of this flyby will settle into history as a moment when humanity watched the sky together, not in panic, but in calm attention. It will be remembered as a rare alignment of knowledge, technology, and timing when something vast passed close, and we were ready to see it for what it truly was, a natural event moving through a universe that is far more active and interconnected than it often appears, quietly reminding us that even close encounters can be moments of learning rather than fear, moments that drift through our collective awareness like the asteroid itself, present for a brief time, then moving on, leaving behind understanding, perspective, and a deeper sense of connection to the space we all share. When scientists talk about close passes in space, they are not thinking about danger first. They are thinking about opportunity. A close pass is like a quiet experiment that nature runs for us, without warning and without control, and Apophis offers one of the clearest chances ever to watch how a large asteroid responds to the pull of a planet like Earth. Even though Apophis is not a threat, experts care deeply about this moment because it lets them see forces at work that are usually hidden over millions of years. Gravity is always shaping objects in space, but it usually does so very slowly. In 2029, that process will speed up just enough for human instruments to watch it happen in real time. Earth's gravity is not just a simple pull straight downward. It stretches and squeezes objects as they pass by, especially when they come close. Scientists call these tidal forces, and they are the same forces that slowly shape our oceans and cause tides on Earth. When an asteroid like Apophis moves through Earth's gravitational field, different parts of the asteroid feel slightly different pulls. The side closer to Earth feels a stronger tug than the side farther away. That difference may sound small, but over time and distance, it can matter a great deal. For Apophis, the difference could be enough to move rocks on its surface or change how it spins as it travels on. Experts believe Apophis is not a solid rock like something carved from stone. Most asteroids are more like loose piles of rubble held together by gravity. They are made of many rocks, dust, and fragments pressed gently together over time. When Earth's gravity reaches out and touches Apophis, it may cause that pile to shift. Small landslides could roll across its surface. Fine dust might lift and resettle. Cracks that have been quiet for ages might open a little wider. None of this would be dramatic in a violent sense, but it would be incredibly valuable to scientists trying to understand how these bodies behave. Another reason experts care is spin. Apophis already rotates as it moves through space, turning slowly, like a drifting log in a river. Earth's gravity could speed that spin up or slow it down, depending on the angle and timing of the encounter. Even a small change in rotation can affect an asteroid's future path, how sunlight warms it, and how forces like solar pressure push against it over many years. By measuring these changes before and after the flyby, scientists can test their models and see if their predictions match reality. The surface of Apophis is also of great interest. Spacecraft and telescopes can measure how light reflects off the asteroid, which gives clues about its texture and composition. If Earth's gravity causes fresh material to be exposed, scientists may see changes in brightness or color. That would be like turning over stone and seeing what has been protected underneath. Fresh surfaces can tell a story about the asteroid's history, its age, and how it has been shaped by collisions and sunlight over time. This close approach is also important for future safety, even though Apophis itself is safe. Every lesson learned from this event helps scientists prepare for objects that may one day pose a real risk. If a dangerous asteroid were discovered far in advance, understanding how gravity affects its shape and motion would be critical. Would a gentle nudge be enough to change its path, or would it break apart into many pieces? Apophis gives researchers a chance to study these questions without pressure, fear, or urgency. Experts also care because this event brings together science from many fields. Astronomers, physicists, geologists, and engineers will all be watching the same object, each from a different angle. Radar signals will bounce off Apophis to map its shape. Telescopes will track its motion with incredible precision. Computer models will run alongside real observations, comparing prediction and outcome. This shared focus creates a moment where science becomes both careful and creative, testing ideas that have been discussed for decades. There is also something quietly human about this interest. For most of history, large objects passed through the sky without anyone knowing. They came and went in silence. Now, for the first time, humanity can watch a large asteroid approach, pass, and move on, fully aware of what it is and why it behaves the way it does. Experts care because this represents progress, not just in technology, but in understanding. It shows how far careful observation and shared knowledge have brought us. Apophis may also help scientists refine how they measure risk. Even though it is safe, tracking its movement requires extreme precision. Tiny uncertainties in position and speed must be reduced again and again. This process improves tools and methods that will be used for every future object. The better scientists become at this work, the calmer and more confident future decisions can be. This is another reason experts pay attention, because each improvement adds to a quiet safety net around our planet. The emotional tone among scientists is not fear, but focus. They see Apophis as a rare visitor that happens to pass close enough to teach us something new. The care they take in studying it reflects respect for the complexity of space, not anxiety about disaster. This careful attention is part of why the public can feel reassured. When experts are curious instead of alarmed, it is usually a sign that the situation is under control. There is also a sense of timing that makes this event special. Many of the scientists preparing to study Apophis have spent their entire careers working toward moments like this. Some helped build the telescopes and radar systems that will be used. Others wrote early papers predicting how gravity might affect a close-passing asteroid. Now, those ideas will be tested not in theory, but in the quiet movement of a real object gliding past Earth. In the end, experts care because Apophis is a reminder that space is not distant and abstract. It is active and connected to us through forces we feel every day, like gravity. Watching how Earth's pull shapes an asteroid helps scientists understand both the small details and the larger picture of how our solar system works. This understanding does not increase fear, it reduces it, replacing uncertainty with knowledge and curiosity with confidence as the asteroid continues on its path, altered just enough for science to learn, but unchanged in its harmless journey forward. Scientists have spent many years carefully studying asteroid Apophis, and one of the most common questions people ask is whether it is dangerous. This question is natural, because when we hear about a large space rock passing close to Earth, our minds often jump to worst-case ideas. Movies, headlines, and old stories have trained us to think of asteroids as sudden threats that appear without warning. But the reality around Apophis is much calmer, more measured, and far more reassuring than fear-driven stories suggest. From the moment Apophis was discovered in 2004, scientists began tracking its path with great care. Powerful telescopes around the world measured its position night after night, slowly building a clear picture of how it moves through space. At first, there was some uncertainty. Early data showed a small chance of impact decades in the future, which caught public attention and made headlines. But science does not stop at first impressions. As more observations came in, those early worries faded. With better measurements, improved models, and years of tracking, scientists were able to rule out a collision with Earth. Today, experts are very confident that Apophis will not hit Earth in 2029. They are also confident it will not hit Earth for at least the next 100 years. This confidence is not based on hope or guesswork. It comes from precise math, repeated observations, and many independent teams checking the same results. Apophis is now one of the most well-studied asteroids we know, precisely because of how close it will pass. Its orbit has been measured again and again, reducing uncertainty to very small margins. One reason people still feel uneasy is because close in space sounds dangerous. When scientists say Apophis will pass close to Earth, they mean close on a cosmic scale. In everyday life, close might mean across the street or in the next room. In space, close can still mean tens of thousands of miles away. Apophis will pass closer than many satellites, but still safely outside Earth's atmosphere. There is no risk of it suddenly dropping toward the ground or breaking apart above us. Another fear people sometimes have is that Earth's gravity could pull Apophis off course during the flyby. Scientists have studied this carefully as well. Earth's gravity will affect Apophis slightly, changing its spin and shape, and adjusting its future orbit. But these changes have already been calculated. The effects are gentle and predictable, not chaotic or dangerous. Rather than pushing Apophis toward Earth, the gravity interaction actually helps scientists understand how similar objects behave. It also helps to understand what Apophis is made of. It is a rocky asteroid, not a fragile cloud of dust or ice. That means it will not suddenly explode or fragment without warning. Its structure has likely remained stable for millions of years. Observations suggest it is a solid body with a surface covered in loose rocks, much like other known asteroids. This makes its behavior more predictable and easier to model. Some people worry that if Apophis did break apart, fragments could still reach Earth. Scientists have considered this idea as well. Even in the unlikely case of surface rocks shifting or small pieces breaking free, those fragments would not pose a serious threat. They would either remain in space or burn up high in Earth's atmosphere long before reaching the ground. There is no scenario supported by evidence where Apophis causes widespread harm. Another important point is how far science has come in monitoring near-Earth objects. Today, astronomers track thousands of asteroids, updating their paths constantly. Apophis is not being watched alone. It is part of a larger system designed to detect, track, and understand objects that come near our planet. If any real danger existed, scientists would know years in advance. That early warning is what turns fear into planning and panic into preparation. It is also worth noting that space agencies are open about what they know. Data about Apophis is shared worldwide. Independent researchers, universities, and observatories all confirm the same conclusions. This openness builds trust and helps prevent misinformation from spreading unchecked. When scientists say Apophis is not dangerous, it is because many groups have reached the same answer through careful study. The idea of danger often grows when imagination fills the gaps left by uncertainty. With Apophis, there are very few gaps left. Its orbit has been mapped with incredible detail. Its size, shape, and motion are well understood. Rather than being a hidden threat, it is a known visitor following a known path. In many ways, Apophis has become a symbol of how far our ability to observe and understand space has advanced. There is also an emotional side to this story. Fear is a powerful feeling, especially when the subject is something large and distant. Space can feel overwhelming because it is so vast and unfamiliar. When something from that vastness comes near, it can stir old instincts meant to protect us. But knowledge has always been the best answer to fear. Each new measurement of Apophis replaces uncertainty with clarity, and clarity brings calm. Instead of focusing on danger, many scientists see Apophis as an opportunity. A close, safe flyby allows us to test our tracking systems, refine our models, and practice observing an asteroid in detail. It is like a rehearsal that helps prepare us for future situations, should a real threat ever appear. In that sense, Apophis makes Earth safer, not more vulnerable. As April 2029 approaches, excitement will likely grow, but fear does not need to grow with it. Apophis will be visible in the sky for some people, a quiet reminder of our place in a moving solar system. It will pass, continue on its journey, and life on Earth will go on as usual. The event will leave behind data, insights, and a deeper understanding of how our planet interacts with its cosmic surroundings. When scientists say Apophis is not dangerous, they are not minimizing risk or ignoring possibilities. They are speaking from years of careful observation and analysis. The story of Apophis shows how science works best when it is patient, precise, and transparent. It reminds us that not every dramatic headline reflects reality, and that calm attention often reveals a much more peaceful truth beneath the noise. As the asteroid continues along its path, it remains a quiet traveler rather than a threat, a moving point of light that tells a larger story about preparation, understanding, and the steady progress of human knowledge as it drifts closer and closer through the darkness of space.
As Apophis moves through space, it follows the same quiet rules that guide everything in the solar system. Gravity is always at work, pulling and shaping objects over long stretches of time. When we think of gravity, we often imagine something sudden or dramatic like an object falling straight down. But in space, gravity is gentle and patient. It reaches out slowly, touching objects long before they ever come close. As Apophis approaches Earth, our planet's gravity will begin to act like a soft sculptor, not striking or breaking the asteroid, but subtly influencing it in ways that scientists find deeply fascinating. Apophis is not a solid rock like a mountain on Earth. It is more like a loose collection of stones, dust, and larger chunks held together by weak gravity. Scientists sometimes describe objects like this as rubble piles. Over millions of years, small impacts and slow collisions shaped Apophis into its current form. Because it is held together gently, it can respond to gravitational forces in ways a solid object cannot. This makes its close approach to Earth especially interesting, because Earth's gravity will not just pull on Apophis as a whole, but also on the individual pieces that make it up. As Apophis draws nearer, different parts of the asteroid will feel slightly different gravitational pulls. The side facing Earth will be tugged a little more strongly than the far side. This difference is called a tidal force. Tidal forces are the same reason Earth's oceans rise and fall, creating tides along our coastlines. In space, these forces can stretch and squeeze objects very slowly. For Apophis, this could mean that its shape changes just a little, perhaps becoming slightly longer or flatter as it passes by. These changes will not happen suddenly. There will be no cracking sounds, no explosions, and no visible damage to Earth. Instead, the process will be quiet and gradual. Small rocks on the surface of Apophis may shift position. Dust that has rested in place for centuries might slide into new patterns. The asteroid's surface could rearrange itself like sand responding to a gentle wave. This slow movement is exactly what scientists hope to observe, because it gives them a rare chance to see how gravity reshapes small worlds in real time. Another important effect of Earth's gravity is how it may change the way Apophis spins. Right now, Apophis rotates as it travels through space, completing a turn every few hours. This rotation has been shaped by past encounters with planets and by the way sunlight pushes gently on its surface over long periods. When Apophis passes close to Earth, gravity could either speed up or slow down this rotation slightly. It could even cause the asteroid to wobble, changing the direction of its spin in a subtle way. This change in rotation is important because it affects how the asteroid behaves in the future. The way Apophis spins influences how sunlight warms its surface, and that warming creates tiny forces that can slowly change its orbit over many years. By studying how Earth's gravity alters Apophis's rotation, scientists can improve their understanding of how small forces add up over time. This knowledge helps researchers predict the paths of other asteroids more accurately, making long-term space monitoring safer and more reliable. Earth's gravity may also reveal what lies beneath Apophis's surface. If rocks shift and dust moves, instruments could detect changes in temperature or brightness. These clues help scientists learn whether the asteroid is tightly packed or loosely held together. Understanding this internal structure is critical for planetary defense planning. If humanity ever needs to gently redirect an asteroid in the distant future, knowing whether it behaves like solid stone or a pile of gravel makes all the difference. What makes this event especially calm and reassuring is that everything about this process is expected and measured. Scientists have studied gravity for centuries, and the calculations behind Apophis's flyby are precise. Earth's gravity is not a threat here. It is a tool for learning. It is acting exactly as nature intends, following predictable laws that guide planets, moons, and asteroids alike. There is comfort in that predictability, even when the event itself feels rare and special. As Apophis passes by, Earth will remain unchanged. Our oceans will continue their usual tides. Our planet's rotation will stay steady. Life on Earth will not feel this interaction at all. All the motion and reshaping will happen far away, silently, in the vastness of space. Yet through telescopes and instruments, scientists will watch closely, turning this quiet encounter into valuable knowledge. There is something deeply human about this moment. For most of history, objects in the sky were distant mysteries. People watched comets and planets with wonder, often mixing fear with imagination. Today we can replace fear with understanding. Earth's gravity shaping Apophis is not a sign of danger, but a reminder that we are part of a living, moving system. Planets and asteroids interact constantly, shaping one another in slow, graceful ways that rarely make headlines but quietly build the structure of the solar system. This flyby also reminds us how gentle many cosmic forces truly are. Space is often described as violent, filled with explosions and collisions. While those events do exist, much of the universe is guided by soft forces acting over long periods. Gravity does not rush. It does not shout. It works patiently, sculpting worlds grain by grain, turn by turn. Apophis is simply another traveler shaped by this steady hand. As scientists prepare for the 2029 flyby, they focus on listening rather than reacting. Instruments will measure tiny changes in motion and shape. Telescopes will track surface details with care. Each small observation will add to a larger picture of how gravity shapes small bodies. This knowledge will not only apply to Apophis, but to countless other asteroids moving quietly through the solar system. For viewers at home, there is no action required and no reason for concern. The idea of Earth's gravity acting as a sculptor may sound dramatic, but it is actually a calming truth. It shows that our planet is not a passive target in space, but an active participant in a balanced system. Earth influences its surroundings just as it is influenced by the sun and moon, creating harmony through motion. As Apophis continues its journey, shaped gently by Earth's gravity, it becomes part of a long story written across the solar system. A story of slow change, careful observation, and growing understanding. A story where even a close encounter becomes an opportunity to learn rather than a reason to fear, and where gravity, steady and silent, continues its patient work across the darkness of space. Behave. When Apophis makes its close pass by Earth, it creates a rare moment that scientists often dream about but almost never get. Most of the time, asteroids remain far away, seen only as small points of light through powerful telescopes. They move quietly, slowly changing position night after night, with little chance for close study. This flyby is different. It brings a large, known asteroid into Earth's neighborhood, close enough for careful observation, detailed measurement, and long periods of study. For scientists, this is not a threat but an opportunity, a natural experiment that unfolds in real time as gravity, motion, and space interact in ways that can be directly measured. One of the most important lessons from this encounter comes from watching how an asteroid responds to Earth's gravity. Gravity is always at work, shaping planets, moons, and even the paths of comets. But its effects on smaller bodies are harder to observe because those effects usually happen far away and very slowly. With Apophis, scientists will be able to see changes as they happen. As the asteroid moves closer, Earth's gravity will gently tug on it, not enough to break it apart, but enough to shift forces inside it. These forces can change how the asteroid spins, how fast it rotates, and even how its surface behaves. Asteroids like Apophis are often not solid rocks. Many are more like loose piles of stone, dust, and rubble held together by weak gravity. Scientists sometimes call them rubble piles. This makes them especially interesting because they respond to gravitational forces in subtle ways. During the flyby, tiny shifts in gravity could cause surface rocks to move, dust to slide, or cracks to open and close. These changes may be small, but they reveal important information about how these objects are built. Understanding that structure matters because it affects how asteroids behave over time and how they would respond if one ever needed to be redirected. Another lesson comes from tracking Apophis before, during, and after the flyby. Scientists will compare its path with incredible precision. Even a tiny change in speed or direction can tell a story about what forces were at work. By measuring these small differences, researchers can test and improve their models of how asteroids move through space. These models are used to predict future paths, assess potential risks, and plan space missions. Each improvement makes future predictions more accurate and reliable. This encounter also helps scientists understand how sunlight affects asteroids. Over long periods, sunlight can slowly change an asteroid's motion through a process known as thermal push. When sunlight warms one side of an asteroid, it later releases that heat back into space, creating a tiny force. This force is very weak, but over years and decades it can change an asteroid's path. By closely watching Apophis before and after its close approach, scientists can separate the effects of Earth's gravity from the effects of sunlight, improving their understanding of both. There is also a human side to this learning process. Apophis will be one of the most observed asteroids in history. Space agencies, universities, and amateur astronomers around the world will work together, sharing data and observations. This level of cooperation helps science move faster and more smoothly. It also helps build systems that can respond quickly if a future object ever requires attention. Practice matters, and this flyby acts as a full rehearsal without the pressure of danger. From this event, scientists can refine how they communicate about space risks. Clear, calm communication builds trust. Apophis shows how early warnings, careful study, and open sharing of information can prevent fear and confusion. Learning how people respond to news about close approaches helps experts explain future events in ways that are honest, calm, and helpful. This is part of science too, understanding not just space but how information moves through society. The flyby also helps engineers test instruments and observation methods. Radar systems will bounce signals off Apophis and listen for the echoes, creating detailed maps of its shape and surface. Telescopes will track changes in brightness and motion. Space-based observatories will collect data without interference from Earth's atmosphere. Each instrument adds a piece to the puzzle, and comparing their results improves accuracy. This helps prepare for future missions, including spacecraft that may visit or even land on asteroids. There is also a lesson about time. Space moves on scales that are much longer than a human lifetime. Apophis reminds us that careful observation over years and decades matters. Scientists first noticed this asteroid in 2004, tracked it carefully, and refined their understanding step by step. The 2029 flyby is not a sudden surprise but the result of long, patient work. This shows how science builds confidence slowly, replacing uncertainty with knowledge through steady effort. This encounter helps researchers think about planetary defense in practical terms. While Apophis is not a danger, it provides a chance to test ideas about how we might respond to a future object that is. By understanding how gravity changes an asteroid's motion and structure, scientists can better design methods to gently alter an asteroid's path if needed. The goal is never dramatic action, but small, careful adjustments made far in advance. Apophis also teaches humility. Even with advanced technology, there is still much we do not know about space. Each close approach reveals new details and sometimes unexpected behavior. That is not a failure of science, but a reminder of how complex the universe is. Learning happens by watching carefully and adjusting ideas as new information appears. For people watching from Earth, this flyby becomes a moment of connection. Seeing an asteroid pass so close brings space down to a human scale. It reminds us that Earth is part of a larger system, moving through space alongside countless other objects. Understanding this does not make our world feel smaller, but more connected, more alive within a wider cosmic setting. As data flows in from the flyby, scientists will spend years studying it, comparing notes, testing ideas, and refining models. Each detail adds to a growing body of knowledge about how asteroids form, evolve, and interact with planets. These lessons extend beyond Apophis itself, applying to thousands of similar objects that share our solar system. Through this encounter, we learn that knowledge grows from calm observation rather than fear, from patience rather than panic. Watching Apophis is not about waiting for disaster, but about understanding motion, gravity, and change in their natural form, letting the quiet mechanics of space reveal their patterns over time as Earth and Apophis briefly share the same neighborhood in the vast, steady rhythm of the solar system. Across the world, long before most people wake up and long after many have gone to sleep, there is a quiet routine that never really stops. Telescopes turn slowly across the sky. Computers listen for faint signals. Scientists check numbers, update charts, and compare notes. This steady work is not dramatic and it rarely makes headlines, but it is one of the most important things modern science does. It is the daily effort to watch the space around Earth and understand what is moving through it. This is what planetary defense truly looks like, calm and patient, built on careful observation rather than fear. Most near-Earth objects are discovered not during moments of crisis, but during ordinary nights. A telescope might notice a faint point of light that was not there before. It appears small, slow, and easy to miss. At first, it is just a dot among millions of stars. Astronomers mark its position and return to it later, checking how it moves against the background. Over hours and days, that movement begins to tell a story. The path becomes clearer and the object earns a temporary name. This early stage is quiet and methodical, and it sets the tone for everything that follows. Once an object is spotted, teams around the world begin to share data. Observatories in different countries confirm the sighting, each one adding a new piece to the puzzle. The goal is simple and steady. Measure where the object is, where it is going, and how fast it is moving. These measurements allow scientists to calculate its orbit, often far into the future. Most of the time, the answer is reassuring. The object passes safely, far from Earth, and is logged as one more known traveler in the solar system. What makes this work powerful is not speed alone, but repetition. The sky is scanned again and again, night after night, year after year. Nothing relies on a single observation. Instead, knowledge builds slowly like layers of paint on a wall. Each pass of a telescope adds confidence. Each calculation sharpens the picture. This process removes guesswork and replaces it with clarity, which is why planetary defense feels calm rather than rushed. People sometimes imagine scientists waiting in panic for the next dangerous asteroid, but the reality is much quieter. The majority of effort is spent on objects that pose no threat at all. These harmless passes are still valuable because they help refine models and improve predictions. By studying safe objects, scientists learn how light reflects off different surfaces, how gravity alters paths, and how small forces like sunlight can gently change an orbit over time. These lessons matter most when something truly important appears. Technology plays a big role in this steady watch, but it is designed to support calm decision-making. Automated surveys scan large areas of the sky, flagging anything unusual. Software sorts through massive amounts of data, filtering out noise and focusing attention where it is needed. Still, humans remain deeply involved. Scientists review results, question assumptions, and double-check calculations. This balance between machines and people keeps errors low and trust high. Planetary defense is also global by nature. Space does not belong to one country, and neither does the responsibility of watching it. Agencies and universities across continents share information openly. When an object is found, its data is quickly published so anyone can study it. This transparency prevents surprises and builds a shared understanding. Even rival nations cooperate in this area because the sky above connects everyone equally. Another quiet strength of planetary defense is time. Most near-Earth objects are detected years or even decades before they could come close. This long lead time changes everything. It means there is room to study, to plan, and to respond carefully if needed. There is no rush, no sudden alarm. Knowing early turns a potential threat into a manageable challenge, and that knowledge comes from constant watching, not dramatic action. Testing possible responses is part of this calm preparation. Scientists run simulations to see how different objects might behave. They study how an asteroid's shape, spin, and material could affect its motion. Missions like test impacts are planned carefully and used to gather data, not to create panic. These tests are quiet proofs that preparation is real, not just theoretical. Public communication also plays a role, though it often lags behind the science. When people hear about asteroids, it is usually during moments of excitement or fear. But behind the scenes, planetary defense teams work to keep messaging steady and clear. They aim to explain risks honestly without exaggeration. This approach helps build trust, even when the topic itself sounds unsettling. One of the most comforting aspects of planetary defense is how routine it has become. What once felt like science fiction is now part of normal scientific life. Students learn these methods in classrooms. Young researchers join surveys knowing exactly what they are contributing to. The process does not depend on heroes or last-minute saves, but on steady systems that improve over time. Even when an object briefly raises concern, the response remains measured. Additional observations are scheduled. Calculations are updated. Uncertainty shrinks with each new data point. Often, what first looked interesting slowly becomes ordinary. This pattern repeats so often that it reinforces confidence in the system. The goal is not to eliminate uncertainty instantly, but to reduce it calmly and responsibly. In many ways, planetary defense mirrors other forms of protection we rely on every day. Weather forecasts, earthquake monitoring, and disease tracking all work in similar ways. They do not stop natural events from happening, but they help society understand and prepare. The value lies not in dramatic moments, but in the quiet accumulation of knowledge that allows better choices. As the years pass, the list of known near-Earth objects grows longer and more detailed. Each entry represents a small victory for awareness. Each one means less unknown space and fewer surprises. The sky becomes more familiar not because it is harmless but because it is understood. This familiarity replaces fear with respect and curiosity. Planetary defense does not promise absolute safety, and scientists are careful to say so. Nature always holds some uncertainty. But the constant watch makes uncertainty smaller and more manageable. It turns the unknown into something that can be studied, measured, and discussed calmly. All of this work continues quietly, whether or not anyone is paying attention. While headlines focus on distant visitors or dramatic possibilities, the real protection comes from this steady rhythm of observation. Night after night, data flows in. Orbits are refined. Risks are reassessed. And life on Earth continues, supported by a calm, watchful eye that never really sleeps. When people hear the name Apophis, it often comes with a sense of fear because it has been talked about so much in connection with close approaches to Earth. But the truth is calmer than that fear. Apophis is a known object. Its path has been carefully measured, checked, and rechecked by scientists around the world. We know where it has been, where it is now, and where it will be for many years into the future. Because of this, Apophis itself is not the real danger. The real concern lies elsewhere, in the quiet spaces of the sky where countless smaller and darker objects move without being seen, unnoticed until they are much closer than we would like. Space around Earth is not empty. It is filled with rocks of all sizes, from grains of dust to mountains drifting silently around the sun. Most of these objects follow stable paths and never come close to us. But some do cross Earth's orbit, and a few of those crossings happen without warning. These are the objects that matter most when scientists talk about risk. Not the famous ones with names and news headlines, but the quiet ones that have not yet been discovered. One reason these unseen objects are such a concern is that space is vast, and many asteroids are small and dark. They do not shine brightly like planets or comets. Instead, they blend into the background of space, especially when they approach from the direction of the sun. Telescopes on Earth cannot easily look toward the sun's glare, which creates a blind spot. An asteroid coming from that direction might only be detected days or even hours before it passes by Earth. History gives us gentle but clear reminders of this reality. In 2013, a small asteroid entered Earth's atmosphere over Chelyabinsk, Russia. It was not detected before impact. It exploded high in the sky, releasing energy stronger than many nuclear weapons. Windows shattered, buildings were damaged, and over 1,000 people were injured, mostly by broken glass. This object was not large enough to cause global harm, but it showed how even modest space rocks can have real effects when they arrive without warning. Objects like that are far more common than large asteroids like Apophis. They pass by Earth regularly, often unnoticed. Most burn up harmlessly in the atmosphere. But occasionally, one is large enough to reach the ground or explode with force. The challenge is not that these objects are unstoppable, but that they are hard to see in advance. The danger, then, is not a single named asteroid on a predictable path. The danger is uncertainty. It is the unknown object that has not yet been catalogued, the one that slips through our detection systems because it is small, dark, or approaching from a difficult angle. This is why scientists focus so much effort on searching the skies every night. They are not worried about Apophis. They are worried about what they have not found yet. This does not mean that Earth is under constant threat or that disaster is likely. In fact, large impacts are very rare. Earth has existed for billions of years, and life has persisted through countless cosmic events. The odds of a major impact in any given year are extremely low. But science is not about fear. It is about preparation. Even low-probability events deserve attention when the consequences could be serious. The good news is that our ability to detect these objects is improving every year. New telescopes, both on the ground and in space, are scanning the sky with greater sensitivity. Automated systems compare images night after night, looking for tiny points of light that move differently from stars. When a new object is found, its path is quickly calculated, and scientists around the world share data to refine predictions. International cooperation plays a key role here. Space does not belong to any one country, and neither does the risk from asteroids. Scientists from many nations work together, sharing observations and models. This global effort reduces uncertainty and increases confidence in our understanding of near-Earth space. It is a quiet, steady process, far removed from dramatic headlines. Another reason the unknown objects matter more than Apophis is that they teach us humility. We are reminded that Earth is part of a larger system, one that we do not fully control. But this humility is not helplessness. It is paired with curiosity and determination. Each new discovery improves our knowledge and gives us more tools to respond wisely. Some asteroids are discovered years or decades before they come close to Earth. In those cases, we have time. Time to observe, to plan, and if necessary, to act. Missions like NASA's DART experiment have already shown that it is possible to change an asteroid's path slightly using technology. These efforts are still early, but they show promise. They exist precisely because scientists are thinking ahead, focusing on unknown risks rather than known non-threats. It is also important to understand that media attention often gravitates toward named objects like Apophis because they are easy to talk about. A name makes a story feel personal and dramatic. But science operates differently. Scientists care less about names and more about numbers, orbits, sizes, and probabilities. From that perspective, Apophis has moved from uncertainty to understanding, which means it has moved out of the danger category. The real work continues quietly in the background. Night after night, telescopes scan the sky. Computers process massive amounts of data. Researchers study how light reflects off different surfaces, helping them estimate the size and composition of distant rocks. All of this effort is aimed at shrinking the unknown, at turning potential surprises into known quantities. For most people, this work goes unnoticed, and that is okay. Its success is measured in the absence of disaster, in the calm continuation of everyday life. When scientists say the real threat is not Apophis, they are not dismissing danger. They are explaining that the greatest risk lies where knowledge is still incomplete, and that is exactly where their attention is focused. In this way, Apophis becomes almost comforting. It is a reminder that when we know something well enough, fear fades. The unknown loses its power when it is studied carefully and patiently. The sky remains full of mysteries, but each one we uncover makes the future a little more predictable, a little more safe, and a little more calm for everyone living beneath it. Humanity has been looking up at the sky for as long as we have existed, but only in recent decades have we truly begun to understand what moves through the space around our planet. Today, when people ask how prepared we are, the answer is calmer and more hopeful than many expect. Preparation does not look like panic or constant alarms. Instead, it looks like quiet rooms filled with screens, steady data streams, and people who spend their lives watching the sky with patience and care. Around the world, scientists now track near-Earth objects every day, not because they expect disaster, but because awareness gives us time and time gives us options. Modern telescopes are the first line of this preparation. These instruments scan the sky night after night, looking for tiny points of light that shift against the background of stars. Some are close, some are far, and most are harmless. Telescopes on Earth work together with space-based observatories that orbit above our atmosphere, free from clouds and light pollution. By combining these views, scientists can spot objects earlier than ever before. Even small asteroids, once invisible, are now detected years or even decades before they pass near Earth. This early detection is one of the most important changes in our relationship with space, because it turns surprise into knowledge. As technology improves, so does the accuracy of prediction. Once an object is found, its path can be traced forward in time using physics that has been tested and refined for centuries. Scientists calculate how gravity from the Sun, planets, and even nearby asteroids may gently alter its course. These calculations are not guesses. They are careful, repeated measurements that grow more precise with every new observation. Over time, uncertainty shrinks and confidence grows. This is why scientists can say with such clarity that Apophis will not strike Earth in 2029, or for many decades beyond. Preparation means knowing what will not happen just as much as knowing what might. Beyond detection and prediction, humanity has also begun to test ways to respond if a future object ever posed a real threat. These tests are not dramatic scenes from movies. They are quiet, controlled experiments designed to answer simple questions. Can we change the path of an asteroid even slightly? How much force would be needed? How early would we need to act? One of the most important steps forward was the success of a mission that deliberately nudged a small asteroid and measured the change in its orbit. The results showed that gentle action taken early can be enough to alter a future outcome. This single experiment shifted planetary defense from theory into reality. Preparation also includes understanding the objects themselves. Not all asteroids are the same. Some are solid rock, others are loose collections of rubble held together by weak gravity. Some spin quickly, others tumble slowly through space. Knowing these details matters because the response to each type would be different. Scientists use radar, light measurements, and even spacecraft flybys to learn about an asteroid's shape, structure, and behavior. Each piece of data adds to a growing library of knowledge, making future decisions calmer and more informed. International cooperation plays a major role in how prepared we are today. Space does not belong to any one nation, and neither do the risks that come with it. Scientists across countries share data openly, compare results, and confirm discoveries together. When one telescope detects a new object, others around the world quickly follow up. This shared effort reduces mistakes and builds trust. It also means that no single group carries the responsibility alone. Preparation is spread across the planet just like the sky itself. Public communication has also improved. In the past, news about asteroids often reached people through dramatic headlines that focused on worst-case scenarios. Today, many space agencies make a clear effort to explain risks in plain language. They share probabilities, timelines, and levels of uncertainty without exaggeration. This helps people understand that most near-Earth objects are monitored carefully and pose no danger. Calm information replaces fear, and understanding replaces speculation. A prepared society is not one that is afraid but one that is informed. Education plays a quiet but powerful role as well. More people now grow up learning about space, gravity, and orbits in school. These ideas become familiar rather than mysterious. When people understand how predictable motion in space really is, sudden panic becomes less likely. This shared baseline of knowledge makes it easier for experts to communicate important updates without causing alarm. Preparation is not only about tools and missions but also about mindset. Another important part of readiness is patience. Space moves on long timescales and real preparation respects that pace. Scientists are not rushing to act unless action is needed. Instead, they watch, measure, and wait. This patience prevents mistakes and ensures that decisions are based on evidence rather than emotion. The ability to wait calmly is often overlooked, but it is one of humanity's greatest strengths when dealing with slow-moving cosmic events. It is also worth noting that preparedness does not mean certainty. There will always be unknowns in space. New objects will appear and new questions will arise. But the difference today is that uncertainty no longer means helplessness. Each year, detection systems improve, models become more accurate, and response strategies grow clearer. Humanity is building a long-term relationship with the sky, one based on observation rather than fear. When people ask how prepared we are today, the honest answer is that we are more prepared than at any other time in history. Not because we can control space, but because we understand it better. We know where to look, how to measure, and how to act if action is ever needed. Preparation has become a steady process rather than a sudden reaction. It is woven into daily scientific work, happening quietly in the background while life on Earth continues as normal. This readiness does not remove all risk, but it transforms risk into something manageable. Instead of sudden surprises, there are long timelines. Instead of panic, there is planning. Instead of fear, there is curiosity and care. Humanity is learning how to live with the reality that we are part of a larger cosmic environment, and that environment can be observed, studied, and understood through steady effort and shared knowledge. When we talk about objects moving through space, especially ones that pass near Earth, time is the most important gift we can have. Early detection is not about panic or fear. It is about awareness, patience, and preparation. When an object is discovered far away long before it comes close, it gives scientists something very valuable. Time to watch, time to measure, and time to understand. With enough time, even large and fast-moving objects become calm problems to solve rather than sudden threats to react to. This is why finding things early matters more than almost anything else in planetary safety. Space is vast and objects move quietly through it. Asteroids do not announce themselves. They do not glow brightly like stars, and many are dark, rocky bodies that reflect very little light. Some are small, some are large, and many follow paths that bring them close to the sun, where they are harder to see. Because of this, discovery often depends on careful scanning of the night sky, night after night, year after year. When an object is found early, it means it was seen while it was still far away, moving slowly across the background of stars. This slow movement allows scientists to track it accurately and predict where it will be years or even decades into the future. When an object is detected late, everything becomes harder. The closer something gets, the faster it appears to move across the sky. Measurements become more uncertain, and small errors can grow into large unknowns. Without enough time, there may be fewer options to respond, fewer chances to double-check predictions, and less opportunity to share information across the world. Early detection removes urgency and replaces it with calm planning. It allows science to move at its natural pace, which is slow, careful, and thoughtful. The idea of early detection is not new. Astronomers have been searching the skies for centuries, but modern technology has changed what is possible. Today, automated telescopes scan wide areas of the sky every clear night. They compare images taken minutes or hours apart, looking for tiny points of light that shift position. These shifts are often the first sign of an asteroid or comet. When such movement is detected, computers flag it and human astronomers take a closer look. This process happens quietly, thousands of times a year, without headlines or alarm. Most objects that are found early turn out to be harmless. Many pass far from Earth. Some are small enough to burn up in the atmosphere if they ever came close. But even when an object is larger, early discovery usually reveals that its path is safe. This information alone has great value. It prevents unnecessary fear and stops rumors before they grow. When scientists can say with confidence that an object will miss Earth by millions of miles, that certainty comes directly from having enough time to collect data. Time also allows scientists to learn more about an object's physical nature. Is it solid rock or a loose pile of rubble held together by weak gravity? Does it spin slowly or quickly? Is its surface smooth or rough? These details matter because they affect how an object behaves as it travels through space. They influence how sunlight pushes on it, how it responds to gravity, and how it might react if humans ever needed to gently change its path. None of this knowledge can be gathered quickly. It requires repeated observations over long periods. When early detection works well, it also allows international cooperation to unfold naturally. Scientists from different countries can observe the same object using different instruments. Radar systems, space telescopes, and ground-based observatories can all contribute pieces of the puzzle. This shared effort builds confidence in the results. Instead of relying on one set of measurements, researchers can compare many and reach agreement. This global approach is only possible when there is time to coordinate and plan. Another benefit of early detection is the ability to test ideas safely. If an object is known decades in advance, scientists can model many scenarios without pressure. They can simulate how tiny changes in speed or direction would affect its future path. They can practice decision-making without real-world consequences. This preparation makes future responses smoother and less stressful, not just for scientists, but for governments and the public as well. Early detection also changes how people emotionally respond to space risks. Sudden discoveries can trigger fear because humans are not comfortable with surprises, especially ones tied to safety. When information arrives slowly and steadily, people have time to adjust. They can hear updates, ask questions, and learn without feeling rushed. This creates trust between scientists and the public. Trust grows when messages are calm, consistent, and based on long-term observation rather than sudden warnings. In many ways, early detection turns space from something unpredictable into something familiar. Patterns emerge. Paths repeat. Objects become known rather than mysterious. What once felt like a threat becomes a subject of study. This shift in perception is powerful. It reminds us that knowledge reduces fear, and patience reduces chaos. Space does not suddenly become safe, but it becomes understandable, and understanding is the foundation of safety. There is also a quiet comfort in knowing how many objects have already been found and tracked. Thousands of near-Earth objects are catalogued today, each with its own calculated orbit. Most will never come close to Earth. Some will pass nearby and move on. The fact that we know this is not luck. It is the result of years of steady effort by people who rarely appear in headlines but whose work protects everyone without drawing attention to itself. Early detection does not mean immediate action. In most cases, it means continued observation and patience. It means watching an object move across the sky, slowly refining predictions as more data comes in. Sometimes early predictions are uncertain, but with time they become clearer. This gradual narrowing of uncertainty is one of the most calming aspects of science. It replaces "we are not sure" with "we understand this well," step by step. If humanity ever needs to change the path of an asteroid, early detection would make that process gentle rather than forceful. Small adjustments made far in advance can have large effects over time. A tiny push, applied years before a close approach, can move an object safely aside without dramatic intervention. This idea depends entirely on time. Without early detection, such gentle solutions would not be possible. In daily life, early warnings help people prepare for storms, traffic, or health issues. In space, early detection serves the same purpose on a larger scale. It gives room for thought. It allows careful choices instead of rushed decisions. It keeps events from becoming emergencies. Most importantly, it keeps fear from filling the gaps where information should be. As telescopes improve and new surveys come online, early detection will only get better. More of the sky will be covered more often. Smaller and darker objects will become easier to see. With each improvement, the unknown shrinks a little more. This does not mean we will ever see everything, but it means surprises will become rarer and less dramatic. The story of early detection is not about dramatic moments or sudden action. It is about quiet nights, steady work, and long-term thinking. It is about people choosing to look ahead rather than react at the last moment. It is about replacing fear with foresight and uncertainty with calm awareness. And as long as the skies are watched with patience and care, time will remain our greatest ally in staying safe beneath the stars. Fear often grows in quiet places, not because danger is real, but because information is missing. When people do not know what is happening, the mind naturally fills the space with imagined outcomes. This is part of being human. Our brains evolved to protect us, to scan for threats, and to prepare for the worst when details are unclear. In the modern world, this instinct can turn harmless events into sources of worry, especially when those events involve space, asteroids, or forces far beyond everyday experience. When a name like Apophis appears in the news, or when an object like 3I Atlas is described with dramatic images, fear can grow even when scientists are calm and confident. The silence between facts becomes loud, and the unknown starts to feel dangerous. For many people, fear does not come from evidence but from distance. Space feels distant, vast, and uncontrollable. We cannot touch it or easily test it ourselves. That distance makes it easy to imagine that something terrible could happen at any moment. Stories, movies, and headlines often reinforce this feeling by focusing on disasters, impacts, and sudden endings. Over time, the brain begins to associate space objects with danger, even when history shows that most of them pass quietly, unnoticed, and harmless. This is how fear slowly builds, not through facts, but through repeated images and unanswered questions. Understanding works in the opposite way. It brings events closer. It replaces mystery with process. When scientists explain how orbits work, how gravity guides objects, and how predictions are made years in advance, the unknown begins to shrink. Instead of imagining an asteroid as a wild object flying freely through space, understanding shows it as something following clear physical rules. These rules are steady, predictable, and tested over time. The more people learn about these rules, the less room fear has to grow. Knowledge does not remove uncertainty completely, but it gives the mind something solid to rest on. In the case of Apophis, understanding has transformed fear into careful observation. When it was first discovered in 2004, early measurements left room for concern. That concern was not panic but caution. Scientists openly discussed the possibility, however small, of a future impact. This openness is part of responsible science, not a sign of danger. Over time, as more data was collected, uncertainty faded. Orbits were refined, predictions improved, and confidence grew. Today, the risk is understood, measured, and found to be extremely low. What once felt frightening is now a subject of study, not fear. This process highlights an important difference between fear and understanding. Fear reacts quickly and emotionally. Understanding takes time. It requires patience, careful measurement, and the willingness to update beliefs as new information arrives. In a fast-moving media environment, fear often spreads faster because it feels urgent. Calm explanations take longer and may seem less exciting. Yet for the human nervous system, calm explanations are far more powerful. They allow the body to relax, the mind to slow down, and trust to form. Understanding also brings perspective. When people learn how often Earth has experienced close passes by asteroids, they begin to see the 2029 flyby as part of a long natural pattern rather than a sudden threat. Earth has existed for billions of years, and during that time, countless objects have passed nearby. Life has adapted, survived, and grown more complex. Humanity is now at a point where it can observe these events with tools and foresight that previous generations never had. This context helps replace fear with appreciation for how far human knowledge has come. Another reason understanding brings calm is that it reveals human agency. Fear often comes from feeling powerless. When events seem beyond control, anxiety rises. Learning about planetary defense systems, tracking networks, and international cooperation shows that humans are not simply waiting and hoping. Scientists are actively watching the sky, sharing data, and preparing responses. Even when no action is needed, the act of monitoring itself provides reassurance. It shows that awareness exists and that surprises are less likely. Understanding also changes how people relate to uncertainty. Instead of seeing uncertainty as a threat, it becomes a space for learning. Scientists do not fear what they do not yet know, they explore it. This mindset can spread to the public when explanations are shared clearly and honestly. Saying "we are still learning" does not have to increase fear. When paired with evidence of progress and care, it can inspire trust. It shows that knowledge is growing step by step rather than standing still. Fear tends to isolate people while understanding connects them. When individuals feel afraid, they often turn inward, imagining worst-case scenarios alone. Understanding encourages shared conversation. It invites questions, discussion, and reflection. Learning about space events together, through calm explanations, helps people feel part of a larger human story. That sense of connection itself reduces anxiety. It reminds people that they are not facing the unknown alone. As understanding grows, the emotional tone around space changes. Instead of dread, there is curiosity. Instead of tension, there is quiet interest. The sky becomes something to watch rather than fear. Objects like Apophis become teachers rather than threats. They offer chances to test models, refine predictions, and learn how gravity shapes the universe. Each lesson learned makes future encounters even calmer, because uncertainty continues to shrink. In this way, knowledge does more than inform. It soothes. It slows the heartbeat and steadies the breath. When people understand that a close approach has been calculated years in advance, that scientists around the world agree on the outcome, and that no sudden changes are expected, the body responds with relief. Calm is not forced. It emerges naturally from clarity. The mind no longer needs to imagine danger because it can see the path clearly laid out. Fear thrives when stories end abruptly, leaving questions unanswered. Understanding keeps the story moving, filling gaps with explanation and context. It turns alarming headlines into longer narratives that make sense over time. For viewers listening late at night, this steady flow of explanation can be grounding. It replaces sharp emotional spikes with smooth continuity. The universe stops feeling hostile and starts feeling orderly, even when it is complex. This balance between fear and understanding is especially important in a world filled with constant alerts and updates. Learning to pause, to listen carefully, and to absorb information slowly can change how events are felt emotionally. Space will always contain unknowns, but unknowns do not have to be frightening. When approached with patience and knowledge, They become part of a larger, calmer picture where curiosity replaces anxiety and awareness gently settles in as the steady rhythm of understanding continues to unfold. As we step back from the details and the data, from the names and the numbers, what remains is a quiet picture of how the universe truly works. Apophis does not arrive as a threat, and it does not come as a warning siren meant to stir fear. Instead, it moves through space the way countless objects have done before it, following paths shaped by gravity, time, and motion. Its close pass reminds us that space is not silent or empty, but active and alive with movement. Yet activity does not mean danger. Motion does not mean harm. The universe can be busy without being hostile, and understanding this difference is important for how we feel when we look up at the night sky. For many people, the idea of something passing close to Earth feels unsettling. We are used to thinking of safety as distance and risk as closeness. But in space, closeness can also mean opportunity. Apophis gives scientists a rare chance to observe, measure, and learn in real time. It allows researchers to see how an asteroid responds to Earth's gravity, how its surface behaves, and how its orbit shifts in subtle ways. These observations help build knowledge that will protect future generations, even if those generations never realize how much quiet work went into keeping them safe. This moment also reminds us that humanity is no longer blind to the skies. In the past, objects could arrive without warning, leaving no time to prepare or respond. Today the situation is very different. Telescopes scan the sky each night. Computers calculate paths years and decades into the future. Scientists around the world share information openly, checking and rechecking their findings. Apophis is not a surprise. It is a known traveler, tracked carefully, understood clearly, and followed calmly. That alone shows how far we have come as a species that watches, learns, and adapts. There is also something grounding about knowing that Earth itself plays a role in shaping these encounters. Gravity is not just a force that pulls things down. It is a sculptor gently guiding the motion of objects large and small. As Apophis passes by, Earth's gravity will reach out and tug on it, not violently but patiently. Rocks may shift. Its spin may change slightly. These small interactions tell a larger story about balance and connection. Nothing in space exists alone. Everything moves in relation to something else, and Earth is part of that larger dance. When fear enters the conversation, it often comes from imagining events without context. A single headline can make space seem dangerous, unpredictable, or threatening. But context changes everything. When we place Apophis within the broader story of planetary science, it becomes less of a shadow and more of a teacher. It shows us how common these objects are, how predictable their paths can be, and how prepared we already are to observe them. Knowledge softens fear, not by dismissing it, but by replacing uncertainty with clarity. This lesson reaches beyond asteroids and astronomy. It reflects how we respond to the unknown in general. When something unfamiliar appears, our first reaction is often to worry. We fill gaps with worst-case ideas. But science offers another approach. It invites patience, observation, and careful thought. Apophis did not demand panic. It asked for attention. And in giving it that attention, scientists transformed a moment of uncertainty into one of understanding. There is also a quiet comfort in knowing that the universe has been active for billions of years, long before humans ever looked up. Stars have formed and faded. Planets have shifted. Asteroids have passed by countless worlds. Life on Earth has continued through it all, adapting and evolving. Apophis is one small part of that long story. It is not the center of it, and it is not the end of it. It is simply a chapter, passing through at a time when we are able to notice. For viewers watching late at night, this realization can be calming. The sky above you is not suddenly more dangerous because you understand it better. In fact, it is safer because understanding brings awareness. Awareness brings preparation. Preparation brings peace of mind. When you lie down and let your thoughts slow, the idea that scientists are quietly watching the skies can feel reassuring rather than alarming. Apophis also shows how cooperation matters. No single country watches the sky alone. Data flows across borders. Observations are shared. Models are compared. This quiet teamwork reduces risk and builds trust in the process. The universe does not belong to one nation or one group. It surrounds us all, and our response to it works best when it is shared. As this story comes together, the message is simple. The universe is not sending us warnings meant to frighten us. It is offering moments to learn, to improve, and to grow wiser. Watching carefully is not a sign of fear. It is a sign of responsibility. It shows that humanity is paying attention, not because disaster is expected, but because understanding matters. Apophis will pass and life on Earth will continue. the sun will rise. Nights will grow quiet again. And somewhere beyond our view, countless other objects will move along their paths, unnoticed and harmless. Knowing this does not make the universe smaller. It makes it feel more familiar, more understandable, and more peaceful. If this gentle journey through space has helped you feel calmer or more curious, you can let it guide you into rest. Allow the steady rhythm of the universe to slow your thoughts. If you would like to continue exploring quiet stories like this, you are welcome to stay, listen, and subscribe for more calm science journeys designed for rest and reflection. And now you can simply relax, knowing that above you the sky is being watched with care, patience, and understanding. Tonight, the stars continue their paths, quietly and predictably. 3i Atlas drifts on, harmless and distant. Apophis passes, observed and understood. And here on Earth, we sleep beneath a sky that has been watched for generations. There is nothing you need to do. Nothing you need to fear. Just rest.